Hello everyone, welcome to our presentation on Iterator design pattern. Before we dive into this particular pattern, let's see what is a design pattern. According to source making, in software engineering, a design pattern is a general repeatable solution to a commonly occurring problem in software design. Using design pattern can speed up the development process by providing tested, proven development paradigm. There are three categories of design pattern, namely creational design pattern, structural design pattern, and behavioral design pattern. Creational design pattern is all about class instantiation. This pattern can be further divided into class creation pattern and object creation patterns. Class creation pattern use instance inheritance and object creation pattern use delegation. Structural design pattern. A structural design pattern is also about class and object composition. Structural class creation use inheritance to compose interfaces, and structural object pattern define ways to compose objects to obtain new functionality. Finally, behavioral design pattern. This pattern is about class objects communication. They are concerned with communication between objects. Some examples of behavioral design patterns are interpreter, mediator, and iterator. The iterator design pattern is going to be developed further right after this slide by Michael Schmidt.
First, let's discuss what an iterator actually is. An iterator is an object that enables a programmer to traverse a container. In our example here, we have a container that holds the letters A, B, C, D, and E. When dealing with iterators, it doesn't really matter what type of data is stored, or even how we implemented the container. In other words, the iterator fulfills the client's need to loop through a container without exposing the underlying representation. Iterators allow us to loop either forward or backward through the container, but we have to start at one end or the other, in this case either A or E, unless we have a reference to another element from a previously used iterator loop. Turning to our periodic trials application, we considered possible areas where we could use the iterator design pattern. We reasoned that iterators would be useful in cases where there is some data to loop through. In the application, one area where we will likely have to use a loop is the implementation of the periodic table quiz. Although there are many ways that the data could be structured, one possible implementation of the quiz would be to store quiz questions in a container. We would then need to have a way to loop through each question in succession. One way to accomplish this task is by using iterators. Although iterators are commonly available in standard libraries in many programming languages, let's briefly consider how iterators can be implemented. A common implementation is by creating a nested iterator class in the container class. This results in the creation of an iterator specially made for that specific container. Now let's discuss the step-by-step process of using iterators and loops. The first step is to instantiate an iterator object. In doing this, it is essential that we use the right type of iterator. For example, an iterator for lists would not be compatible with a binary search tree. Second, the newly created object should be initialized to the iterator for the first element. This can usually be accessed by calling the begin method on the iterator object. The third step is to extract the needed data from the iterator reference. In the case of the periodic table quiz in the periodic trials application, we would need to extract the element data such as atomic number, atomic weight, element name, and element symbol. Next, after we are done using the data for a specific question, we will need a way to loop to the next iterator. This can be accomplished by using the increment operator. Once the iterator has been incremented, we can extract the data for the next question and repeat this process until all elements in the container have been accessed. The final step is letting the program know when to end the loop. This is accomplished by having a special end or null iterator to let the program know that you have passed the last element of the container. There are three advantages of iterators. First, we can access contents of a collection without exposing its internal structure. Second, we can support multiple simultaneous traversals of a collection. And third, they provide a uniform interface for traversing different collections. Here are the disadvantages of iterators. First, they are less efficient than using a regular for loop, and applying the pattern can be overkill if your app only works with simple collections. And finally, an iterator takes more system resources.
Thank you, Michael. Now our recommendation. When to use an iterator? We recommend you use an iterator when you don't want to expose the internal structure of a collection. Also, when you have a complex collection. In all cases, use a simple for loop when possible.
Finally, these are the sources that we cited for our presentation. This presentation was made by Michael Schmidt and Freddie Coco. We hope you enjoyed our presentation. Thank you.